Okay, now that the full script has run, I'm going to check the report to see how things went. So I can see these are the names of all the data files that were run. And I can see how many raw and final epochs were in each data file. And so this is where I'm going to look at this report and several variables in this report to evaluate which data files I need to go back to and have some individual attention to that particular data file to see if it can be recovered or cleaned in an alternative way, or if it just needs to be removed from the final list of data sets to move on to the next step. So the first things I look at are, raw and final epochs. And so, for example, we can see here for subject 3001-1, they only have one epoch. And there is no -2, so I'm guessing this participant quit at some point, would be my guess. So this person is probably going to be removed. The rest of these people have plenty of final epochs. Here's one removed, three, that's plenty fine. Here is a subject where for both sessions, almost all of their epochs were removed. So that is probably, I'm going to have to go back and look at those. Other things I might look. So this is a great case, as I can look over here at EOG. So eye-blink correction was conducted. That does often fail, resulting in too many epochs being removed. It says 0 as complete, so that means it failed during the preprocessing base script, and it failed at the Chan fix. So the Chan fix step, if we go here, so we can go to the parameters, and we can look at the different steps. So Chan fix identifies and interpolates bad channels within each epoch. So this is a custom script I wrote, and it goes into each epoch, looks at all the channels, identifies whatever bad channels there are, and interpolates them just within that epoch, and then goes on to the next epoch. So this is a great way to identify channels that are usually good, but then they have, a couple artifacts or something like that. It will interpolate those. So the fact that both of these data files failed during that step, this function has some logic in it where if more than a particular number of epochs are rejected, it will just fail the person automatically. And that is down here in the cleaning parameters, and that is Chan fix bad Chan threshold. No. Maybe there isn't that. Maybe I'm misremembering. I mean, this tells you how many each epoch, how many bad channels can be within each epoch without it rejecting the epoch. But either way, 71 removed epochs. Not so good. Oh, probably what happened, why it actually said it failed during Chan fix. And it removed, so if it removed 71 channels, meaning there's only one epoch left, EEG Lab might have gotten confused and thought that this was a continuous data set. That's one reason why it may have failed. That's possible. Anyways, so one thing I noticed right away, so all these bad reference 1 and 2, mean reference 1 and 2, standard reference 1 and 2, these are all referring to the reference channels, so the linked mastoids. And so it looks at percentage of bad data points across all epochs, the mean value of across all epochs, and the standard deviation across all epochs. And so this is just a way to evaluate, are the reference channels that we're going to re-reference to, are those appropriate? And so as you can see for most of these, there's like none. The mean reference is pretty reasonable, and the standard deviation is pretty reasonable. But then here, for these two bad ones, you see 31 and 40% of the data points are above or below plus or minus 150 millivolts. So this reference 1 channel is bad. The mean is way above what other ones are, and the standard deviation is huge. So I'm guessing that if I were to go back and not re-reference to this channel, then the chan fix would be just fine. So again, looking at this row, and as we can see here, it gave us not a number. It didn't even get to this point where it counts how many epochs per cat code. All right, so once you've identified bad data files, what you'll want to do is record the row number on this report into the troubleshooting script. So this troubleshooting script is basically just like this run script. It doesn't have this top half, but it's basically this main script with, and then instead of having this base script, base function do all the pre-processing steps, it actually has each step written out, so you can run each step individually. So the first thing you'll have to do is make sure that this bottom section here, right here, where you're building the input and output names, that this is the same as here in your run file, to make sure it's this. Because sometimes, depending on how your data files are named, you may have to add things to these variable parameters. And so if you do that, you have to also do it over here. But since I didn't change anything, I won't have to do that. And so this is generally how I do it. So what I do is I make a little note section above for all the data files I'm going to go back to. So I'll record the row number, then the actual subject and session number, and then what's wrong and what I did to fix it. So as I said, for the report, you want to record the row number. So it's these two data files, 12 and 13, and it's 1009, 1 and 2. So I'm going to say 12, 1009 -1. Too many epochs. Rejected. Probable bad reference. And then 13. Now, the reason I'm doing this is because then when I go back to this script at a later time, so if it's being pre-processed and I notice there's some artifacts in the later processing steps, I might come back and see, well, gosh, which were the problematic data sets? And I can look to see which data sets I had to hand clean, because that may be important. So to run an individual data set, which is exactly what I want to do, I'm going to take this row number and I'm going to put it in here as the SI number. The SI number refers to that for loop here in the run script. So in the run script, in this main section where there's the for loop, which run through each participant, it has this SI number. One thing I will also mention, if you're running this troubleshooter in a MATLAB session that you did not run this main run script, before you can run the troubleshooter, before you can actually load up a data file, you'll have to run the top half of this run script so that it specifies all the paths, loads the parameters and the subnames and all that stuff. Then you can come back and do this. All right, so for doing the troubleshooting, you can just run this section by section. Oh, one other thing I'll mention. So we've identified bad data files from the report. The other way I identify bad data points is by going into eegplots. And so here are the screenshots from each data file. And so again, this is the first 5 epochs of the final process data. And so I'll look at each of these and try to determine, is this a good data file, or do I need to go back and look at it to see if I can clean it up even better than it is? And so I can just click through each of these images relatively rapidly once I get a handle of what's good and what's not good. So in general, what I'm going to look at is down here in the corner. And again, this is an EEG lab plot. And so it's a screenshot, so none of these buttons work. And so I'm going to look down here at the scale. So this is the scale of this plot. And values, generally I look for, if the value is under 100, I'm not overly concerned. So a scale of 51 and having the waveforms this size, I consider that to be plenty fine and appropriate. I'm a little concerned you see this section where everything is kind of doing the same sort of motion. That can indicate that either there's a bad eye blink channel or a bad reference channel, because either of those steps in the pre-processing will take artifacts in 1 or 2 data channels and put them into all of the channels. So in general, if you see an artifact that runs across all channels in these plots, that may indicate that one of those steps is bad things are happening. But because it's only in one little section, and then you see over here things are okay, I'm not overly worried about it. Again, scale of 51, I think this is probably just fine. And I will mention, the data is almost never going to look perfect. There's going to be some little bits of funkiness. All right, so I'm just going to click through. Scale of 45, data looks good. All right, so here is one subject where there's only, it looks like 3 epochs. So this person, and I think we saw this, where oh no, this is actually only 1 epoch, because it's more spread out. It's 3 seconds. So this is someone who we're going to have to reject. All right, now here is a subject where we can see from their plot they have some somewhat problematic channels. There's a few here, what I would call fuzzy channels. These are not completely bad channels. They're probably not completely disconnected from the scalp, but it looks like they don't have a great signal. If I were to guess, it probably means that these were relatively high impedance when the data was collected. So if you really wanted to be fastidious and try to remove all possible artifacts from your data, you could go back and manually remove and interpolate these channels. Generally, I don't do that if it's just, a couple few fuzzy channels, because the fuzzy channels don't introduce systematic artifacts. And so, generally speaking, once you average across epochs, across participants, the averaged analyses that we do, I do not believe are impacted by these very much. So I generally leave them. Again, if there were a lot of them for an individual subject, I might be worried. But just a couple here and there, I generally leave it. But again, you could go in and fix these manually. as you can see, so this is 1004 session 2, and this is session 1. So you see these fuzzy channels, scale of 19, and then here too, scale of 25. It looks like they've calmed down a little bit. So I'm guessing that again, that impedance, the gel is soaking into the scalp, impedances are getting a little bit better. Another factor in why I'm not overly concerned about these is, again, this scale of 19 is very low. That means it's very zoomed into the data, and yet things are not looking big and ugly. So the lower the scale number, the more confidence that I feel that the data is, it's pretty good. This is fine. 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 Looks like fine. So here's an example of one fuzzy channel, and this is, significantly different than the other channels. So it's fuzzy and it's relatively big. So this might be a data file that I might go back to. Again, a scale of 32, I'm not super concerned. That's a pretty good scale factor, but this might be worth going in and manually rejecting and interpolating. So it looks like for subject 1010, that one was bad the whole time. And if I look at it, there may not be a lot of EEG brain sources here. It may be mostly artifacts. So again, it might be worth interpolating. That's fine. That's fine. All right, that's it. So really only probably maybe these might be worth going back to. 10.1 and 10.2. All the rest of them seemed fine. And again, you could probably let this fly. If this was a data set with 200 or 300 data files, I might ignore that. But we only have a few here, so I could probably get into it. All right, and we're doing 109, so I can then add this. So I would go to the report and see again 10.10.1, 10.10.2 is row 14 and 15. Channel 15. Okay. So now that I've identified all the bad data files I want to go back to, I'm actually going to go back to them. So again, I have loaded up SI equals 12, so we're going to load up this one. So I ran this section, and this run section button is going to be your friend. So here this section loads the data. This is, here we go. Step 1, this Chan name fix. This just corrects some of our PyCorder or idiosyncratic little weird things. Oops. It also filters the data, resamples, puts in the channel locations, removes the baseline, and then each of these steps, or most of them, will plot the data and save it. So you can kind of take a look at the data at each step of the preprocessing, so you can see, oh gosh, what's going on with the data. And as you can see here, with a scale of 129, there are a couple data channels that are doing crazy things. And again, that's probably what's causing the problems. So here we go, this next section, epics. Whoa, okay, so clearly there are a few bad channels in here. So at this point, I've epicked, baseline corrected, and so I know that the next step I have in this is an optional section where I can manually remove channels that are obviously bad. Because for several steps in the pre-processing, it's going to evaluate the fit of a particular channel, how good a channel is, based on all the other channels and the statistics of all the other channels. So if you have a few data channels that are really bad, it will skew everything so that it might not later find channels that are actually bad, but just not crazy bad like these. So it is good to remove channels that are exceptionally bad because it will ultimately result in cleaner data. So I would probably try and remove each one of these data channels, and we see, so it's a little tricky trying to figure out which channels they are because EEG Lab just has the channel numbers, and while this is a live EEG Lab plot, um, at least on our server, sometimes the windows and drop-down menus tend to bug out and not work very well. So the best way I've found to identify which channel it is to use the mouse and kind of scroll over and then to look down here because it will tell you what channel you're on, the time, and the value. So if you look at the channel and the value, I can go here and I can say, aha, channel 10 minus 360. So that's that bad channel. Whereas if I was up a little bit, channel 9, value of 7.8. So I can kind of say, oh, yep, channel 10 is the bad one, or at least one of the bad ones. So what I'm going to do is in this array here, I'm going to start to put in the channel numbers just like I did here. One thing to note that sometimes when you open up plots, it will bug out and you won't be able to actually type here. I generally just tend to hit the open button and then close it, and that'll sort of debug it. So 10 is already in here. One thing to note, channel 10 is one of our mastoid channels for brain vision. So again, just like the report said, for these data files, one of the references was bad. And as we can see here, that's definitely true. So we can have that channel removed and interpolated, and then we can re-reference to it. Because the mastoids, there are channels around it that can be referenced. Bugged out again. Okay, so definitely channel 10, and then probably these as well. So it looks like here 73 is bad, 74 is okay. Looks like 75 and 76. So 73, 75, 76. 83, 84. Now I know these last channels here are those are peripheral channels, so I don't think I can add those. Actually, let me check here. Yeah, so 95, 96, 97, those are all peripheral channels. So those won't be able to be interpolated because there is no location. 84 and 85. So 74 is one of the iBlink channels. And I think we just listed that one. Oh no, we didn't. Huh, okay. Good. So 73, 75, 76, those are all live channels. and then 10. All right, so now if we run this section, it's going to just remove those channels and interpolate. And as we can already see, data looks much better. So in this old plot, the scale is 165. Now here we have a scale of 67. We see channel 10 got fixed. It looks like one of these channels, or maybe two of them, didn't really get interpolated well. So 86, it looks like, is still pretty funky. Oh yeah. And 84 and 86. Okay. So 84 and 86. So I generally tend to save these little arrays so that if I have to go back to this data file, I already know. So I'm going to run this again. So it's going to remove and interpolate those two channels. All right, so now suddenly everything looks good. We got a pretty good scale. I can start to scroll right. And so even though that one channel gets funky for a little bit there, it's also looking pretty good for most of these other epics. So what is this? Oh, that's one of the, that's probably SCR. So I don't even need to worry about it. All right, so this looks like clean data. So this section is really the workhorse of the troubleshooter, where a lot of bad data files you can fix with this, just this one section. Okay, now this step cuts out the worst percentage of epics. And that would be here. Epic first cut is the worst 5% of epics. But I actually don't have that step activated because in this slow picks task, we typically have low trial count, so I disable this step. For most other tasks, go, no go gambling and such like that, where there's a lot of trials for every cat code, I generally have this in. So since it's not activated, I'm going to skip it here in the troubleshooter. So in any of these sections, you can just not run it. So here this is going to identify bad channels. Data's looking good. This is going to be iBlink correction. I will note that as you're running this and these plots come up, don't be too trigger happy in closing them, because it has to plot it and then save it. And if you just by chance close it before it has a chance to save, it'll throw an error. Not a big deal, but you might be confused by why you're getting an error. All right, so this is re-referencing to linked mastoids. Looks pretty good. Again, you have that peripheral channel that's doing weird things. So this is the chanfix function, where before it was rejecting 71 out of 72 channels. But here it looks great. Didn't really reject. So currently 70 epics in the data set. So it just rejected a couple. All right, so that's pretty much done. So if I want to save the eeglab.set, I could run this section, but I don't need to. And then here is the saving PTB, well, converting it to PTB, and then saving it. So that was successful. And then this last section just integrates this subject report into the final report. So now when I go back into the report, we can see that 1009-1, the one I just ran, it's been updated. So now it was complete, chanfix worked fine, and at the end of the day we have plenty of epics per cat code. So the rest of the troubleshooter has some optional sections which I've developed, for specific things that go wrong. So one thing that sometimes goes wrong is the Graton eye blink correction fails. If one of the, or if multiple or all of the eye blink channels are bad, the Graton, which is a regression method, will not work. It will work, but it will put tons of artifact into the data. And so here is two sections which you need to run if you want to run independent component analysis. This will run the independent component analysis, and then you can basically select components from the ICA to reject. Ideally, you would just reject the eye blink components, and then re-reference to average. Well, this will re-reference to average anyways, and then you can just reject the components that have the eye blinks in them. So that's sort of an alternative thing. And then there's some other things, other sections here that probably don't apply. So that's it. So I've run one data file through. So now I would basically do the exact same procedure for file 13 because that's the same subject. So what I can do, and again, this is why I saved this. I can copy and put this up. So now I have a record of what I did. First, I ran this. I guess I should put this actually after it. Oops. So this is telling me, aha, I rejected these channels and then I rejected those channels. So I'm guessing if I did exactly the same thing for this data file, I would get about the same thing. And for this data file where there was one fuzzy channel, again, I can just run through it, put that one channel number in, and it would interpolate it. So I would just run it up to here, put that one channel number in, and then just continue on. All right. So that's troubleshooting and manually cleaning data sets. So you just do that for every one of these, and the ones that you just can't end up cleaning, you have to add to the list of subnames you just can't use, and then the ones that you've recovered, good times.